Hello and welcome to another GCSE revision video, and in this video we're going to be looking at the cosine rule. Now the Pythagorean theorem, as c squared is equal to a squared plus b squared, is absolutely amazing and so useful for right angled triangles, but wouldn't it be so cool if we had something similar that could work with all triangles? Well, that's pretty much what the cosine rule is. The cosine rule that's closest to our memorised Pythagorean theorem says c squared is equal to a squared plus b squared, which you will know is the Pythagorean theorem, but then we subtract 2ab cos c. Okay, well, I made the point that the cosine rule is kind of like a general purpose Pythagorean theorem, but let's just have a look how that works. We've got a triangle with two legs A and B and the hypotenuse is C. So the cosine rule will tell us that c squared is equal to a squared plus b squared minus 2ab cos c. Okay, fair enough, but what is cos c? Well, c is 90 degrees, and if we can remember our unit circle, I can quickly try and sketch out a quick unit circle here. Remember that we defined cosine as the x coordinate and sine as the y coordinate on a unit circle. So this is cos, the coordinates will be cos, comma, sine. And if we draw a circle, not pretty lousy circle, but if we draw a circle, then 90 degrees is up here. So the x coordinate is 0 and the y coordinate is 1. So the cosine of 90 degrees is actually 0. So c squared is actually equal to a squared plus b squared minus 2ab cos 90 degrees. And as we just said, cos 90 degrees is 0. So this becomes 0. Now anything multiplied by 0, so 2 times a times b times 0, anything times 0 is 0, so this whole term just disappears. Which leaves us with c squared is equal to a squared plus b squared, which is Pythagoras' theorem. Any of the variations of that though work though, so you could have a squared equals b squared plus c squared minus 2bc cos a, or b squared equals a squared plus c squared minus 2ac cos b. Basically what we're saying is the side that you're looking for squared is equal to the sum of the squares of the other two sides minus 2 times the product of the other two sides multiplied by the cosine of the angle between those two sides. And let's try and find out why we have to subtract this 2bc cos a or 2ac cos b or 2ab cos c. Let's take the top formula and we'll derive it. Okay, so the first thing we're going to do is drop a vertical line from the vertex that is angle B straight down to the base, and that's going to divide the base into two parts that are not necessarily equal. One we're going to call length D and the other one is whatever's remainder, which is length, the whole of length B minus length D. Now this line is perpendicular to the base, so we can now use our SOHCAHTOA rules and say that length D is equal to the hypotenuse C multiplied by the cosine of A. Remember, adjacent over hypotenuse is equal to cosine of the angle. And the other thing we're going to do is take that vertical line and we're just going to label it H. H for height, because that's the height of the triangle. We can also use Pythagorean theorem to say that c squared is equal to d squared plus h squared. Well, if c squared is equal to d squared plus h squared, then d squared is going to be equal to c squared minus h squared. Okay, just in case that step wasn't too obvious, we've got a right angled triangle. We've got length d along the bottom, length h going up, that's the height of the triangle, and then length c, which has become the hypotenuse of this right angled triangle. So we're using Pythagoras' theorem, and we're saying that c squared, remember the square of the hypotenuse is equal to the sum of the squares of the other two sides, so c squared equals d squared plus h squared. Now all we're going to do is rearrange this a little bit. So we want to get d squared on the left hand side. So this is just simple formula manipulation. So if I take this h squared and I move it over the equals, we get c squared minus h squared is equal to d squared. And it's the property of equals that if the left hand side is equal to the right hand side, then the right hand side is equal to the left hand side. So therefore d squared is equal to c squared minus h squared. And that's all we're saying. Now the other side, the b minus d side, we can use the same Pythagorean theorem to say that b minus d all squared is equal to a squared minus h squared, which is exactly the same reasoning that we just did to get d squared is equal to c squared minus h squared. Okay, so just a quick review in case that wasn't as obvious as it should be. So Pythagoras' theorem will say that if this is a triangle where one of the lengths is h, the other is b minus d, and the hypotenuse is a, then the square of the hypotenuse is equal to the sum of the square of the other two sides. So that's h squared plus, and this is our b minus d, all squared. Now if we want to get b minus d squared on the left hand side, we can take this h squared across, so the sign becomes negative. What we're effectively doing is subtracting h squared from both sides. So this is a squared minus h squared is equal to b minus d all squared. And remember, b minus d is the length here. Now, if the left hand side is equal to the right hand side, then the right hand side is equal to the left hand side. That's what equals means. So that means that b minus d squared is equal to a squared minus h squared. And that's all there is to it. However, when we expand out the b minus d squared, we get b squared plus d squared minus 2bd. Okay, so just in case that last bit wasn't obvious, b minus d squared is the same thing as b minus d times itself, which is b minus d. Now what brackets means is that everything in the brackets needs to be multiplied by everything in the brackets. So we're multiplying both b minus d by the b minus d. So this is the same as b times b minus d plus and this is a negative d here, so that's negative d into b minus d. So now we've got to multiply everything in the one brackets by the b, and then everything in the other brackets by the negative d, and add them together. So this is b times b, which is b squared, plus b times negative d, which is negative bd, plus negative d times b, plus negative d times negative d. Well, that negative times a negative is a positive, so this is d squared, or positive d squared. Now negative bd plus negative db, well, db is the same as bd. That's the commutative property of multiplication. A times b is the same as b times a. So we can actually simplify this to b squared. If we're adding a negative, we might as well be subtracting. So this is subtract 2bd plus d squared. And if we want to keep the squared terms together, what we can do is say this is b squared plus d squared minus 2bd. Now, since b minus d all squared is equal to a squared minus h squared from the Pythagorean theorem, if we substitute in the expanded form of b minus d all squared, we get a squared minus h squared is equal to b squared plus d squared minus 2bd. Okay, so all I was saying there is we already know that b minus d squared is equal to b squared plus d squared minus 2bd, which we just shown. And we already know that b minus d squared is equal to a squared minus h squared. And what we're saying is if this and this are both equal to the same thing, then they both must be equal to each other. So a squared minus h squared is equal to b squared plus d squared minus 2bd. And if we rearrange that, we can get a squared is equal to b squared plus h squared plus d squared minus 2bd. Okay, so to rearrange this, it was really simple. All I've done is taken this h squared and I've plonked it over here. So a squared is equal to b squared plus h squared plus d squared minus 2bd. However, d squared is equal to c squared minus h squared, which we already discussed. So if we substitute c squared minus h squared for d squared, we can get a squared is equal to b squared plus h squared plus c squared minus h squared minus 2bd. Okay, that was a bit of a mouthful. Let's just try to explain what I was saying there. We already know that d squared is equal to c squared minus h squared. We did that almost towards the very beginning. Now what I'm saying is, if we take this d squared here out of the picture, we can replace this d squared with c squared minus h squared, because d squared is equal to c squared minus h squared. So if d squared is equal to c squared minus h squared, where we saw d squared, we can just substitute in c squared minus h squared. So what we get is a squared is equal to b squared plus h squared plus c squared minus h squared minus 2bd. Now those h squareds are going to cancel each other out, so we can simplify it to a squared is equal to b squared plus c squared minus 2bd, and we are laughing now. Okay, so why are we laughing? Well, we can tidy up this mess now. These d squares over there are no longer needed. Get rid of this. In fact, we can get rid of everything except this, which I can move up to here. Get rid of that. Tidy that up. Now what we said was that this, we've got plus h squared here and minus h squared here. Well, if I give you 10 apples, then I take those 10 apples back again, you're left with whatever you had to begin with. So adding something and then subtracting the same thing, they just cancel each other out. So these guys go. So bye bye. And bye bye. So this horrible mess just became considerably easier. And doesn't this already start to look a bit like that cosine rule that we started off trying to derive? In fact, the only thing that's different is this d here. But d is equal to c cos a, which we said right at the very beginning. And when we substitute that in, we get our cosine rule. A squared is equal to b squared plus c squared minus 2bc cos a. And if you can remember right back to the beginning, we did say that d, or length d, is equal to the hypotenuse, which was c, times the cosine of angle A. And if d is equal to c cos A, then all we do is take our c cos A and substitute that in where we see the d. So bye bye d, and we get our c cos A. And that is the cosine rule. Okay, in the next video, I'd like to actually show how we can use this formula that we've just derived. So until then, if you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in the next video.